This video will give an introduction into robotic total stations and multi-stations. It will give an overview of the benefits of using robotic total stations instead of manual total stations, and introduce each of the features that make it possible. The video focuses on Viva and Nova total stations and multi-stations that are powered by LEICA Captivate. A total station is basically an electronic instrument that measures and records angles and distances. A manual total station requires that the user sights the target through the telescope and manually adjusts the horizontal and vertical screws to align the crosshairs to the target. A robotic total station is motorized, which means the telescope position can automatically turn, whilst in addition, using automatic target aiming, the total station can automatically search, aim to, and follow a reflective target. There are many benefits in using robotic total stations instead of manual total stations. Imagine you have to survey this road, stake out a few points, and measure detail on the side of the building. Using a manual total station, you would need a second person continually aiming the instrument to the target to measure the points. Using a robotic total station, finding the prism, aiming and measuring can all be automated, meaning the points are measured much quicker and you are more productive. With a robotic total station, the instruments can also be operated completely remotely by only one person, meaning as well as being quicker, you also save the costs of the second person and are in complete control of the data collection and quality. Let's see the one-person survey in action. The instrument will quickly find the target on the pole of the surveyor and lock to it. As the surveyor moves around, the instrument will follow the target, meaning they can fully concentrate on coding and measuring points. There are no delays waiting for the instrument to be pointed to the target, or struggling with communication, as there would be with a manual total station. Staking is also much faster, with the surveyor being guided directly to the points being staked, using graphics and sound. Again, no delays waiting for the instrument operator to manually aim and measure, and repeatedly wave or shout instructions to the surveyor. When it is needed to measure or scan a grid of points on a building, a robotic total station is also much faster. By defining the area to be measured, many hundreds or even thousands of points can be automatically measured in just a few minutes, meaning a massive time saving over using a manual total station. So in summary, there are many benefits in using a robotic total station. Faster finding the target, faster aiming and measuring points, no need for a second person, fewer communication problems, fully in control of data collection and quality, much faster measuring or scanning a grid of points. Now let's have a look at what features make all of this possible. We will look at automatic target aiming, automatic target lock, power search, and imaging. Automatic target aiming means the instruments can automatically aim to a reflective target, such as a prism. With the instrument roughly pointing towards a target, one button press will search, find, and automatically aim to the target, and the measurement will be made. There is no need to sight the target through the telescope and manually adjust the horizontal and vertical screws to align the crosshairs to the center of the target. Automatic target aiming provides fast and precise aiming and measuring, and reduces user fatigue when making repetitive measurements, such as during monitoring or topographic surveying. It works with any standard reflective prism, meaning there is no need to use a specially designed target, which requires batteries and adds weight to the pole. To learn more about how it works, please watch the automatic target aiming video. Automatic target lock means the instruments can automatically follow the target when it moves. This is known as being locked, as the crosshairs are locked to the target. Combined with continuous distance measurement, the position of the target can be continuously tracked, which allows rapid measurements to be made without the need to keep manually aiming at the target. Automatic target lock means the instruments can be operated remotely. There is no need for a second person to operate the instrument, meaning there are no delays with finding the target, aiming, measuring and communicating. Again, it works with any standard reflective prism, meaning there is no need to use a special target that requires power. To learn more about how it works, please watch the automatic target lock video. Power search is a feature which enables the instrument to rapidly locate a reflective target in any direction. Power search first locates the target and then precisely aims to it. With power search, there is no need for the user to point the instrument towards the target. Together with automatic target aiming and lock, the instruments can be operated completely remotely. Power search is useful in a busy measuring environment where there are many interruptions in the line of sight to the target, and the target needs to be repeatedly and quickly located. To learn more about how this works, please watch the power search video. Imaging can be used to gain even more functionality from a robotic total station. Imaging allows the view from the instrument to be displayed onto the screen, using either an overview camera or, in addition, an integrated telescope camera. The image on the screen can be used to help with aiming the instrument without the need for the user to look through the telescope. Used together with robotic functions, the instruments can also be aimed by tapping on the screen, which will turn the instruments towards that point. This function prevents the need for the user to look repeatedly through the telescope, for example when making measurements to non-reflective targets such as buildings. This video gave an overview of the benefits of using robotic total stations and gave an introduction into the key robotic features. Other videos will look into each of the features in more detail, so do watch those videos if you would like to learn even more. Thanks for watching.